additive manufacturing course. From here, Anoop sir will be taking on. Anoop sir, please carry on. Thank you everyone. Good evening again.
Sure. Thank you, Madhugar, for handing over me this session. So today is the third day of our course. So today, as we know, that we have to install our Cura softwares for further development of the course. So might be possible that everyone who is having laptop with them has installed their software. So I'm a guide for this course. Anoop Kumar, founder of CEO, experiment for Karimnagar, Delhi West. I'm postgraduate from Usman University, and today we have to start with 3D printing processes. Like how a 3D printing a model comes into from virtual to a realistic model. So for 3D printing process, we have four stages, but for only for 3D printing, we are having three stages, but we consider design also as a first initial stage for it. So here, for quality assurance, we have to first define our design in a good mesh size. Then pre-processing, we should know about how to give support, what should be the layer height, and how many raft angle overhangs we should provide so that we can get a good quality. Second thing is that when we start to print, that how we must keep our bed clean, that how should plug in the power, where should we put our 3D printer to have a good look, like we can easily work on that. How to level our bed are a part of printing process. Post processing we are having, where we do post processing on a model to get support out of it, because lots of supports will build on the model, and we have to remove it by different hooks and tricks, because to give a fine smooth finish out to the model. As for pre-processing, we will take our model into a slicer where we already give us a command to of our printer. See, here clearly 3D printer is mentioned on the left hand corner of the Cura printer. Right? In between there is a virtual bed on which our model has been placed in the center, and on the right hand side corner we are having different settings for pre-processing. This is when we print a model, that how our bed should be, is like that. Post-processing, as we already discussed, that in post-processing we do post-processing mainly for removing supports, but sometimes we have to give it such fine smooth structure. So here on the right hand corner we can see the difference between before and after. One helmet is there in black color. You can everyone can see that this material is ABS, and when we do a post processing on ABS, it will convert into a shiny surface. On the in the downward image, we can see that with the help of a plucker or plier, we have to remove the extra support, such that to get a clear image what we have printed. So starting with our printer, I will share you. This outcome. as we already installed our software, so we need to go to the start menu, and for Windows 7, we have for Windows 7 and Windows 10, we can go to taskbar, right here, Cura, right, Cura, and the ultimate Cura version will be coming on the top, then we have to click on that. Otherwise, there will be a shortcut will be visible on the desktop, and there is a if we have pin Acura in a taskbar, then it will come on the taskbar also. Don't do anything. Just open your software and don't do anything with them. This is the interface we are going to see. We are on the left hand side. Left hand side, we will know our printer over there. Can you please comment that you have opened your software? Don't worry about it. We come to that thing also. Open, okay. You will be getting an option add network printer. Like the window you are seeing, you might be seeing the same window what I am seeing. So to get started, we will have to get started with it. Then we have to agree the agreement. Then next, we will do next. Then here, it asks for to add the printer. So as we start working on a Ender 3D, realty Ender 3D printer. So from printer option, we'll scroll downwards and go to Creality 3D. This is the option available in all Cura software. From there, click on that Creality 3D, then move downwards, then we will find our printer, Creality Ender 3. Just click on this button and press next. And next. Now our end. Now we'll set this will option, and we can see our printer on the left hand corner where we can manage our printer settings. Just click here, clicking on manager. From there, machine settings. From here, we can see our printer settings. Okay, our printer is having x-axis 220 degrees, 220 mm, y equal to 220 mm, z height equal to 250 mm. So we can print the volume of 220 into 220 into 250 mm cube. This is our limit of the printer. Beyond that, we can't go. So here the build plate size and say we are having a rectangular heated bed because we are having a heated bed with us, and G code use every printer use Merlin G code, and this is the start code. You will get to know about these codes in CNC or when we go to advanced or expert coaching. This is a basic course. Will not focus on that thing. Okay. Then you should close your window. Okay. Then everyone from now we should know how to deal with this interface. From what are the options available. This is a place from where we can get upload our models. Basically, all models are in STL format. So we'll open an STL format, and here we can see on the screen that we have uploaded a STL model file, which we are going to slice in few minutes. So from here we can open STL file, or other options are also there. We can simply drag and drop. We can simply first delete it. On the left side, you can see there is a STL file over there. You can simply drag it to the bed. Then it automatically gets into this interface of your slicer. And here, after this, we can see our printer over there. Even we can add more printers over there. Next is what printer nozzle size we are using. Our printer nozzle is of 0.4 mm hole diameter. There are several other nozzles available of different diameter up to a range of 1 mm nozzle. And which material we are using, whether it's generic ABS, PETG, nylon, PLA, PC, PVA, TPU. From here we can choose our software, choose our material which we are going to work on. And there are few companies which are popular around the globe, which are having already their settings like that. You can see, but for our purpose, we go with generic material, that is PLA for a start introduction. Then here on the right hand corner, we can see our printer settings. So this first profile is showing, it is talking about the layer height. We can manage our layer height by clicking on the circle, and we can manage our print height of a print. Here we can give an infill of ranging from 0 to 100. Means like while we print, we don't print 100% because it will simply increase the weight of the model, and it depends upon the application we are using it for. Just for aesthetics, if we are giving 10% support, then it's quite good. If you want to use it as a prototype and we want to like put a fan on it or a motor on it to run just like a Digo fixer to fix a motor on it, so we need higher strength because it will deal with the torque of the shaft which is generating. So we can increase depending upon the application we are using. Or there is another option gradual infill as we move from bottom to top. We start printing from bottom to top. This percentage of infill will vary according to the height of the print. Maximum it will go up to 90% till the top. Okay. Here is the option for generating support, whether we want support or not, or uh, an addition I told you about yesterday, that skirt, brief, and raft. So just to enable it, we can give a support. So from here, we can after giving every print after setting of all print set parameters, we can give a command slice. So this is the preparation mode we can see, and here is the preview. Available to us. You can see there on the left hand corner, oh sorry, right hand corner, there is a bar over there where it is showing 210. 210 is nothing but number of layers which are going to be printed in future when if we give the print. Then we can, if it goes down, you can see each layer at what number you want to see 112 layer. You are seeing if you want to go to basic side, then you can see basic side. So if you want to see it from top view, just here on the left hand side corner there are different views are available. If you want to see in isometric view, 3D or isometric view, we can click on that. For front view, next button. For the from the top view, next. For the side view, left hand side view and right hand side view. So we want to see the top from the top, just to see how the supports are gradually increasing. This is the first layer, as I mentioned over there, addition. So by default, printer will take trim settings where the count of the lines is around 20. As we go from first layer, you can see there is much gap between this cross section. As we are moving gradually up, this gap is coming down. Say from here, the next suppose will start, and gradually the support will increase. There's a trust. So this is just a basic or glimpse of it, right? How the interface will look like and what we can work on. So now coming to the next thing, commands and how we can manage a print on the bed. After clicking our model, as left click on the model, this translation window will come. If we move this green arrow, our model will translate into y-axis. It will pick our red arrow, then the model will translate in x-axis. But if we can translate our model in z, even though in z-axis. But there is a default setting that whenever you will put it in, you can't be put your model in here you can't print your model in in here, so we should need a surface or a bed from where we can start print. So there's a default setting of this Cura that the print will come and fall down on the bed in whichever position it is. Okay, the next will be our rotate tool. So from here we can, while clicking this bed, we have changed the angle or the position of our model. And when we will translate this in even z axis, it will fall down in the same position. So here, when we come, there are another option, reset option. So the model will come to reset. Reset. And the third option here on is for the manipulation is scaling factor. If we click on any one of this scaling box in whether it's Z or Y or X, it will scale uniformly, because here on the option there is a tick on the uniform scaling option. Now we'll do it 100%. See, all if we change one, then other tools are automatically changing. So now when I remove this and when I untick this uniform scaling, if I now scale it down, it will stretch in x-axis. It will stretch in y-axis. It will stretch down in z-axis. And as we can see, when this model is coming out of bed and the dark picture of this model is appearing, this means that you can't print because this is coming out of your limits. See, as we are going on the bed, as we are moving away from the bed, this we can't even slide. Here option will come unable to slide because it is crossing printer's limit, which are already defined in the print manager machine setting, that our x-axis is 220, y-axis is 220, and z-axis is 250. So I'll click on this uniform scaling and give command 100. So that then there is another setting called mirroring, from from where we want to mirror, which plane we want to mirror: front view, side view, top view. is how we can mirror our model. From here, these are advanced settings. Don't worry about it. Now we come to the it's okay when we translate here. Sometimes it go beyond it and we want it to be at the center. If this lies within the region of a bed, it will automatically get stick to the bed. But if we are moving ahead of the bed, we can put it anywhere. This automatic sticking to the bed comes on in the wallet sticking to the bed. Okay, so when we translate our model and we have translated it to some another location, and don't want to use this translation thing, then we'll simply right click and center selected model. This will bring model to the center of the build plate. And here, if you want to do, we can delete selected model. And from here again, we will call our model into the window. And if you don't want to call, there is an option that you can call a model again and again to print. But without going and dragging it into this interface, we can go simply right click and select multiple selected model. So here we'll select number of copies we want to make. If you give number 4, then extra 4 will be generated. Extra 4. How many extra numbers of models you want? And there is a shortcut to this right click and multiple selected model is Control M. This Control M will work only after we have already selected our model. If our model is not selected, this is selected model, because outer we can see a blue boundary which indicates that our model is selected. If we click on somewhere on build plate or outside somewhere, then our model is not selected. Then we have to press our model and do Control M. And how many extra number of models we want to print, we can give number S3. As we are seeing, all models are auto arranged but not looking fit for printing. So we'll click select all models, then click center all models. Here, each and every model will come at the center. From here, we can select all models and arrange all models. Here we can see one model is going out of it. So simply take it off and place it as we want to align this model. And print times also depend upon how near a second model is placed to another. Because if you drag this model, with all 4 models on different corners, now you can see how much time we are getting in on this different format. The print time will be around 11 hours 27 minutes. Select our model, arrange all models. This is for change the orientation. See the difference between time and how we arrange model depends upon how we are arranging our model. Okay, so I'll share you a G drive link so that you can download this STL model. Just wait for me. I'm sharing your. This is the link from where you can download a few of the STL files which you're going to work on. It's shared your drive in. Just wait for me. Select on. If you want to delete this thing, you can simply Control plus D. This will clear the whole build plate. Okay. I had given link where you will find these three models which we will work on. And these three models I have given to you all on which we will going to work. This portion, no other format is supported by any of the 3D slicer. Only STL files are supported by Cura. If you go to NetFab, then we can directly import a file like part file. Directly model file can be imported in NetFab software. But in Cura and Simplify 3D and Tinkercad, only STL models can be imported. other other models are other formats are not compatible with these slicers. Okay. So this is our normal window. There's only a few settings I told you about it, but when we go our custom settings, here on the right hand corner we click custom. Here we can see many options available, just like we are having like just a default recommended setting. So there we will find a specified profile given by Cura for Ender 3D, that if you click on different qualities setting, infill percentage, material, speed, if you click on material, generic, APS, this one. See, when I select ABS for ABS as a material, here the material temperatures get changed automatically from 200 degrees Celsius to 230 degrees Celsius, and bed temperature from 60 degrees Celsius to 80 degrees Celsius. If we again go to change material ABS, generic, PLA, we can see here already defined settings for different materials. Here the model color also has been changed. See, material temperature comes 200 degrees Celsius and 60 degrees Celsius. There are different profiles already pre-installed in this software for different materials. Okay, so from here we can see there are already saved profiles are there, already saved profiles, standard quality. So standard quality is there of height 0.2 mm. If we are going to for little low quality, the height will increase up to 3 mm, 0.3 mm, and the layer height will be around 0.28 mm. See, the layer height change. The layer height change to 0.28 mm, and shell thickness will decrease from 1.2 to 0.8. It depends upon which profile we are using. According to that, we can manage our. In tomorrow's session, we'll see how to create our own profile and how to use these custom settings options made available other than recommended. Okay. So we'll just for a see if we slice all three on the same build plate, how much time it is going to take. It will take around 6 hours. Okay. Here in preview, we'll see different layers. As I change our settings to standard, then custom settings. Okay, if you slice in custom settings, then if you slice in recommended settings. Look how our model will look like. There is a periphery around brim structure is there. Default brim structure will be formed around the model. And if we go to custom settings and then slices, because now we have changed our set. Now we have changed our settings. Now it slides. See the difference between. Now we can see there is a skirt made on the outer periphery that will define that where our model going to lie. We can't see supports because we had not enabled our support. If we enable our support, then support will be generated, and support formation of supports also takes time. See, from 6 hours, the print time goes up to 9 hours because now we have generated support for our structures. This is the main model and this is the rectilinear support system. By taking the help of supports, we can create a model. Okay, this is, I'll stop here. Okay. If anybody is having any questions with them, then they can answer. They can ask questions. So, if anyone is having any questions regarding today's session, no, we can't extract a CAD model. We need extension. Yeah, we need a different extension. Like as only STL, we can import only STL in Cura. We can't import a CAD model directly. We can't that CAD model is having a format of part .part, but we can't import it directly into the Cura. We need to export that CAD model into STL file. From there, we can import it in our Cura software. I shared a link. You all should download this link for practice after the session because you need a special hands-on after this session because if you miss anything then it's your loss only. I'm giving you the link again. Sorry, don't this is the wrong link I given. This drive Google Drive link I had given in the description right now. In the last link I had given this, you can download all 3 files from here for our course. We will work on these files only. Do anyone have any questions regarding to today's session? You can ask me. One tell me about how to change section to STL. Okay. In your softwares like SolidWorks, Pro E, and Unigraphics, AutoCAD, there is a export option available. Export option available in the when you save your file. There is an save. You put save as and select different format for that. It depends upon you can type Google that how to change CAD model to STL format because what software you are using it depends upon on the process of process of generating from CAD extension to STL extension. How Okay. Yes, we just change. Gaurav Kumar, your answer to your question is that we have to change our printer setting or profile setting. As I already told you, from here, when we go to our preparation session I'll show you once. Wait, I'll share you the screen. Here, there are two modes. One is preview mode and one is preparation mode or pre-processing mode. You can. We will change our material from generic PLA to generic ABS and discard the settings. Okay. Then it will automatically change the temperature of which material we are using. See in material settings, it will automatically take settings for ABS that is 230 degrees Celsius and build temperature 80 degrees Celsius. If you want to print, if you want to change our material from ABS to different materials just like nylon, okay, sorry, PETG, okay, then you can see in material, you can see a change. The printing temperature changed from 230 degrees Celsius to 215 degrees Celsius and build plate temperature changed from 80 degrees Celsius to 70 degrees Celsius. This is how we can print the same model using different print settings. Okay, if if we generate our code, just we start slice. We generated our slice. Okay, then we'll save this file, dimension calibration, and see what material we're using. Generic PETG. So we'll add here PET T just to distinguish between what profile and what G code we are generating for which material. Save it. Okay. Now here we can say that PETG file dimension calibration has been saved. Now we'll change from here generic ABS and slice again. Then save, then change the name here and type ABS space enter. So now you can see next we can print all three models or any one of these models with different materials with different profile settings. See here we are having different codes for same models. We are having PETG code for these three models and we are having ABS codes for these three models. In printer, when we give a command to a G code or a specified G code, then from there we can choose which if we are using ABS material, then we will click on the ABS print setting Okay, and in printer, and if you are using PETG, then we'll click on PETG print. Anyone is having any doubt, or Gaurav, your doubt has been cleared? Gaurav Kumar, is your doubt got clear? And okay, great. Not only you, everyone should practice what I am teaching you on the same way you are need to practice. Do anyone is having any queries or doubts regarding today's session? Anyone is there who have any questions or doubts or want to know something about what we have done in previous 2 days classes? You want to ask anything new? Any query you can ask. Okay. So Madhukar, you are there? Madhukar, are you there? Okay, I'll share you tomorrow the PDF of the material. And you can even search by your own on it. Tomorrow, definitely I'll provide you the material reference PDF. But you can also go and research because we have plenty of time to do that. And you can, yes, YouTube link is available. Uh, it's available on your WhatsApp, your WhatsApp group. Every day we share. Are you Gopinath? Are you on WhatsApp? Okay. So,
Gopinath speaking, sir. Using WhatsApp, sir.
Using no like on WhatsApp group. Are you joined on WhatsApp group?
Yes, sir. Yes, sir.
On WhatsApp group, we are sharing our YouTube channel link. Soon as we actually now we are just managing the quality of the video what we are recording. Okay. And we are editing it. Soon as your course will be done, then there might be possibility from the day after tomorrow. Every day we'll start posting from first session, second session, and third session simultaneously. Okay.
Okay, sir. Thank you.
How much it cost? Okay. So, this we don't print total aircraft engine. We work on a specific things. If you want to print a small, if I'll give you an example. If you are printing, metal printing will be used for this. If you are printing a size of 10 mm cube, 100 mm cube, that will cost you around 30,000 rupees. For any metal printing, approximately cost is around 30,000 rupees for 50 mm cube. 50 mm cube, sorry, 50 mm cube. If you are printing a volume of 50 mm cube, then it will cost you around 30,000 rupees for that much volume only. 50 mm means 5 centimeter into 5 centimeter into 5 mm, 5 centimeter. That will cost you around 30,000 rupees. From there you can. That's why I'm saying that we don't build total aircraft engine, because we know we can do casting process for that. But for specified design where RAM, jets or space applications are there, where the manufacturing is so complicated or complex that even a CNC machine of 11 axis is not able to do that thing, then we use 3D printers for filters. We can use it for filters, micro machining processes. Where the micro machining process is not applicable, then we looking forward towards 3D printing. That. Anything else? Akash, is your doubt clear, or you want any other explanation or anything? Don't hesitate. You will not. I am not going to deduct your marks. You can ask freely. Or as I said, we are making a community for all of you, where we can share our experiences. If anyone is having any doubt, then you can just join any of these platforms, Facebook, Instagram or Telegram, with extension of AI3DP, All India 3D Printing. AI3DP, All India 3D Printing. Any of these platforms, Facebook, Instagram or Telegram. If you join on Telegram, then it will be a Telegram or a Facebook page. Then it will be helpful for you for getting new updates always. If you follow us on all three of these platforms, then that will be much better, because for any update, a single update is possible, you can get to know about that at very easy. Okay, sure. Okay, I'll share you Telegram link. This is the Telegram link. You can. Yeah, there are different materials available in transparent format, like transparent carbon fiber. carbon fiber you are saying, it depends upon the filament. If you are having a carbon fiber filament of transparent material and don't have any, like we are having few materials transferred, we are having PLA, TPU as a transparent material. But I never have seen any carbon fiber because I've seen one material of carbon fiber that is black in color or red in color. There are two carbon fiber materials available that are black and blue in color. Okay, so as for today, hello, Gaurav Kumar, is your query got? Oh, sorry, Gaurav. Deepak, God, is you okay with the answer?
Yes, sir. Yes, sir.
Okay. Yeah, it is possible to get the same strength because same strength as we are getting in 3D printing, 3D metal 3D printer. Sorry, we will get the same strength in metal 3D printing. In PLA automotive, okay. In automotive industry, the whole car has been printed. Whole car, apart from engine or chassis, like we are having a metal sheet, or we can say a body sheet metal. Every that sheet metal part has been done on a car. Can you share the list of any printed? Okay, I'll wait. I'll show you. See here, we are having a whole 3D printed car. Apart from this mechanical work, mechanical thing that steering wheel, steering rod, this wheel structure and gearbox, engine and transmission system. Apart from that, every aspect of this whole body is 3D printed. Okay, for now I'm closing this session. We'll meet tomorrow. I think everyone has downloaded their files. Okay, and we'll start and whatever I taught you today, you will do a hands-on after this session and keep practicing. Okay. Okay. Thank you, Deepak. Bye for now. Bye for now. Good night. Have a nice day, all of you. That's you can leave. You can leave the meeting.